CQNet, this is November 9, Zulu Bravo, calling you all to the reInvent Net, CQNet. Everybody heard that before? We got amateur radio people? Oh yeah, okay, I got some. So let me get this clicker rolling. So yeah, I'm Nathan Hiscock, and this isn't just for amateur radio operators, it's also for cloud aficionados with AWS. And so my role actually day-to-day is in sales, marketing, and alliances with SellaCloud. We're a global multi-cloud solution and managed service provider. But I also teach cloud and use AWS as our platform at Ball State University. And I've put together Project Skiggy, which is just my amateur radio hobby AWS platform. I do net control. I'm from Indianapolis, and I do net control for our Aries groups, if you're familiar with that. And I'm kind of lazy sometimes, and I want to not have to write things down in your logbook while I'm sitting there doing this, and I want to see where the stations who are reporting in at without having to know where, their call sign maps to. So I thought one day, you know what? I'm going to see what I can do with AWS Transcribe. And that was the genesis of this project. So who here knows nothing about amateur radio? Got a few? Okay, so I'll give a quick background, and probably there's people here who know more about this than I do. But amateur radio is a reserved spectrum on the radio frequencies that is reserved for us as citizens to get licensed and then experiment with. We have innovation learning, we have recreation, we do support for things like marathons, and I do POCAR, which is like orienteering in the wilderness. And then we do things like emergency communications, where we report in weather spotting, we do traffic. If there was ever some sort of system-wide wireless communication being down, we help pass messaging along. So I help out with a lot of that, play with a lot of that, and I'm sure a bunch of you do. My passion in amateur radio is experimentation and just getting things to work. Hi, Shai. So anyway, so the genesis of my project was, I wonder if I can just automate some of this and see a picture of what it is that we're saying. So at any moment in time, hopefully the background, I recorded a net and I'm not hearing it right now, but the background of that net comes in. And so here you can see this.
W9NES, I'll run with.
There we go. There it's coming in. So we have a very scripted way that we manage communications in amateur radio emergency services. And so a lot of that is very easy to then plug into a training model for a translation. And so I first tried it just seeing how it would do without any configuration, kind of like probably what's going on at the top here. And it didn't do very well because the ham language is rather esoteric, right? We have a lot of acronyms, call signs. But the cool thing is it's very structured, right? So I'm like, man, this ought to be something we can at least translate. So for those who don't know, a net, you're listening to traffic, you're writing down stations, you're mapping reports. If there's a hail spotted over on the other part of the city, you're marking where that was, what size the hail was. All that stuff, we should be able to train Transcribe to pick out. So that's what I tried to do.
With traffic or announcements, please come now.
So I'm kind of working backwards, right? I want to automate and visualize what's going on. So what do I need to do? I need to be able to translate that speech to text, right? So first, it's got to be pretty accurate. Second, I need to identify and log stations. I've got to pull out my call sign. So mine's November 9 Zulu Bravo, but others, there's a certain map and pattern. So that's pretty easy to configure because we have rules. We have to get information about stations. So guess what? The FCC has a whole bunch of data. And then also, and I'll get to this later, we can triangulate signals with something like an antenna array. That's what I really want to do, and I haven't got to yet. And then, of course, we can show location. So everybody's done a Google map or whatever. You're dropping a pin, throwing up metadata about the location or what they're saying, right? Wouldn't it be, what I want to do is drop that and have a bubble pop up, kind of like Waze. You're driving around and there's little spots. It should all be done. But it's challenging, right? Because amateur radio, for one, it's got to be really simple and it's got to be really inexpensive because we have volunteers, right? No one's paying millions of dollars, to transcribe, amateur radio emergency communication services. But the good thing is we have a lot of rules, regulations, and formats on how that communication and call signs are identified. So that bodes really well for being able to use a good language model. And then, of course, ease of support, right? It's all going to be volunteers. So how do we make it really simple? Well, I like simple anyways, and my favorite quote from Einstein is, "The best design is the simplest one that works." So here's kind of the sprints I set up. And again, this wasn't that structured for me, just kind of a backwards mapping. First, transcribe that audio. Second, we're going to transcribe that audio and collect that information from the FCC database so we can display it. No different than QRZ. Okay, there's a big public website for those stations. Public information. All traffic on amateur radio bands is public, just like a radio station would be. And then I want to scale it and add different user interface and user experience features. So that's kind of the path. And then the end game for me is, anybody heard of Kraken RF? Okay, a couple. I want to get different arrays and position them around so then people don't even have to report necessarily where they're at. Say they're a mobile station or they're portable, and they go, hey, I'm at 10th and Emerson. Guess what? I don't even have to necessarily send that back to some sort of mapping engine to figure out where they're at. I know because of where that signal came. So triangulation, no different than what they do with your phone and the low accuracy location with triangulation between antenna towers. So I'm not going to read this for you, but phase one, transcribe it. So the first time I tried this, it didn't really work well because the way that we speak and some of the words we use are highly technical and it's esoteric. So I had to build a custom language model and then a custom vocab to go with. And so what I found is that worked actually pretty well. Vanilla translation was like 50%. If someone's talking about a highly detailed engineering thing, it didn't pick that up very well. What I learned really fast is that the translation jobs cost per audio time and not per processing time. So you can run that bill up really fast. Thank goodness I put a budget alert of $1 on that thing before I spun it up because it hit that fairly quickly. So yeah, custom vocabs and language models and transcribe run up that cost a lot faster. So anyway, it's a good first try, right? Try it, fails, try it, fail, get better. So fun. Hey, and then guess what? This is the really cool thing. So the first time I did this, I think I built like a scraper to go through websites, pull content down, format it into a language or training content for a language model. And the cool thing about that was it worked, but the bad thing was it took me, a couple months on and off, because this is a hobby project, a couple months on and off programming this thing. And then ChatGPT went pretty public. Hey, you and so the cool thing about that was, I'm like, holy cow. I can just tell ChatGPT to go out to the website, format it a certain way, and build my training content for me. So I could point it to IEEE or some sort of engineering site or QRZ or the FCC, gets all that language and trains it, and that did significantly better and faster. So it took that time it took me to build that from like weeks to a few days. So definitely use Gen AI. It was very cool. So phase two, I had a transcription. It was working pretty well. Then let's build a UI on top of that. So really simple UI, straight up JavaScript. But you can see, let me see if this laser works here. Oh, no, we're going back. I don't have a laser button. All right, so over on the right station, hey, we've got herd stations. So the cool thing is I was able to build a custom language model with a vocab that picked out those signs. And then, of course, the transcription. Real simple application, transcribe, a little bit of Lambda to do some data imports from FCC, and then use an Amplify to orchestrate everything. Not the most sophisticated thing. Real easy. I like easy. So this is our first proof of concept, and you can kind of see how it's set up. Over here on the right, you've got bubbles where those are stations and station maps that come in. If I were able to hover over that, you would see some station data about that, right? And you can imagine what you could do to expand on that. And you can see the transcription over here still isn't perfect. It's proof concept. but it's better,
W9
right?
That was Sean.
So
89.
this is version 1 of Project Skiggy. I use it for myself. And the cool thing is, the other thing I can do is I have to provide reports to some of the emergency communications groups, and I can export from Hertz stations, and then I don't have to spend 30 minutes formatting an Excel spreadsheet, because again, I like to be lazy and automate everything I can.
All right, KG9 East.
All right, so yeah, phase 2. Definitely needed to refine that model. I completed the POC in 3 days. From the first one, took me a month or two. 50,000 stations generates a 1.5 meg custom vocab file, which is way too big. So I have to re-architect the way that transcription functions. Probably can't use a custom vocab file. So I've got some ideas on how I might approach that. And then there's a giant FCC database file that you got to pull down to process.
Yep, sorry.
But pretty easy to do.
When I was saying your call, my apologies.
So some results of that first version, I got 37 out of 50 stations on the first proof of concept. Not bad. Okay? And the other thing that was really cool was it could hear things my ear couldn't, because it was still recorded. So if somebody was really distant, you know, on a HT or something, it could still pick that audio out. So it heard a couple stations I couldn't, because it was so low in volume. And about 80% of general ham jargon was, translated well, etc. So that's cool. So phase 3, I want to take it like to the next level, do a more full stack app, and and then some of the other things that we could do, right? If someone calls and say, hey, this is November 9 Zulu Bravo, I'm portable. Maybe I can drop a little handy talkie icon there, maybe a car for the mobile station. But there's a lot of phrases that we all use that we should be able to train into this and pick out. So, and then there's certain language that, at least in my area, that we use. When a call sign gets repeated by 2 different callers, that's kind of a confirmation that that station's present. So that's easy. Not only did we hear the station, but we check it off. So that's some of the other things. And then, of course, a lot of times we're calling in a traffic report or something like that at a location. And if I'm saying my location, yeah, we should be able to go look that address up and throw that icon on a map moving around. So I kind of think of it like Waze. Wouldn't it be cool, like amateur radio for Waze? And then I have an announcement, I have traffic. Like every time I get that on a net operation, I'm like, oh, I got to flag them. I got to remember to come back. I'd really rather the UI just kind of show that they have a question, kind of raise their hand, and then I don't have to remember. Again, I like to automate everything. And then I'm gonna end this pretty fast here. So here's what I really would like to do. And so if anybody wants to share their ideas, I'm always open to it. But I call it Release the Kraken RF. And I think there might be a couple technologies that do this. But for those that don't know, it's basically an antenna array hooked up to your phone that has GPS. And so it's got direction finding capability. And so it tells the strength. And if you can kind of see in the bottom left, bottom right, it kind of shows signal strength and a direction. So if you put 3 of those, again, you can use triangulation to find out. So a lot of people use Kraken RF to do like fox hunts or find spurious signals coming from wherever, and interference, that kind of thing, to kind of shut it down so it's not bothering people. Sometimes we have people that hang up on a repeater, and then you can never get them off until you find them where they're at. Their battery dies. But if you put 3 of those, right, you should be able to triangulate that. So that's going to take a little more time and money, because you got to get those things up high. You got to pay for the equipment. It's got to be hooked into computers and etc. So anyway, that's my project. Feel free to connect with me on LinkedIn. There's some more about the project on my website there. But